In this video, we'll learn about the motion graphs for this class in their simplest form. Okay, let's begin with a position time graph. So let's start with the simplest case. We have an object that is not moving. Okay, so if the object's not moving, that means it is not going to change its position. So let's say the object was at this position over here. So that means the object will remain in that position until something happens. Let's sketch the corresponding velocity time graph. Well, if the object is not moving, it does not have any velocity. Therefore, the velocity would be at 0 all the time. And we can say it has 0 velocity. Furthermore, we learned that velocity is the rate of change in position. So if you're trying to find the slope of this line, well, it doesn't have any. It'll be 0. That's why we have 0 velocity. And the corresponding acceleration graph, well, there's no velocity. There isn't any acceleration either. So the acceleration has a value of 0. Okay. Now let's make it a little bit more interesting. Let's say we have an object moving at constant velocity away from the origin. Because we know that velocity is the rate of change of position, that means our graph will have a positive slope, starts at the origin. There you go. Now let's sketch the corresponding velocity time graph. Let's say the velocity, just for the sake of argument, let's say the velocity is 3 meters per second. That means when we draw our corresponding velocity time graph, we need to find the location at which velocity has a value of 3, let's say here. And that will be our line. It is constant, that means it is not changing, therefore it is always at a value of 3. And we can simply say this is constant positive velocity. Because acceleration, again, is the rate of change in velocity, if we're trying to find the slope of this line, well, there's no slope because it is constant velocity. Therefore, acceleration will be 0. And just so you know, any and every time you see the words constant speed or constant velocity, that should tell you right away that there is no acceleration. Again, if you have constant speed or constant velocity, that means no acceleration. Okay, now let's have negative velocity. We're moving toward the origin at constant velocity. So that means the value of our line should go back to the origin. Okay? The vertical component should go down towards 0. So that means the slope is going to be negative. Let's say we started at this location and then we got to the origin. Notice how the vertical component is going down until we hit 0 or the origin. That's why we have moving toward origin at constant velocity. Let's say this velocity is going to be, let's go for the same thing. It looks almost the same. Negative 3 meters per second. This velocity, although it's negative, does not mean it's slowing down. It just tells you it's moving backward. Okay? That's all it's telling you. So the corresponding velocity time graph should be drawn in such a way that you can clearly see that the velocity is negative. So let's say the value for -3 is here. That means our line will be straight and there. And because this is constant velocity, even though it's negative, we know that the acceleration will be 0. And then I forgot to write this is constant negative velocity. And let's add that we have a velocity of -3 meters per second, just so we can make that connection between the slope of this line and this line. Likewise, I'm going to add 3 meters per second here, just so we can keep making that connection. In the next video, I'll show you what happens when we have acceleration.